Welcome back to Kubernetes Crash Course. In this module, we will be discussing about Kubernetes volumes, why we need it, or what problem Kubernetes volume is solving. As we know, in Docker also, we have same sort of issues, right? Where we map our external hosts inside Docker containers for volume persistency. As you might have seen, whenever a container is deleted, along with the container, the data which is present inside the container is also deleted. So to tackle this issue, what we did is we came up with a different volume methodology. That is, either we create a external volume, that is host volume, we'll attach it directly inside your container, and whenever even the container is deleted, the volume will be persisted on your host machine. Same sort of things that we have in case of Kubernetes also. That means whenever a pod is crashed, right, automatically because of n number of reasons, so the data which is present inside the pod is also deleted along with it. To persist the data inside the volume, what we do is we will build or we will create something called as volumes, right, which are external mounts, right. So we will see all the examples, what is PV, what is PVC, how to create persistent volume, how to claim this thing onto a particular option, how the bind works, PV and PVC binding works, then what are the access mode also we have, everything we'll check it, right. So let's go and try to understand this particular option. Alright people, as you can see here, right, Kubernetes volumes solves two main problems with containers. That is, data inside a container is lost if the container crashes or restarts, right. That is same as that of your Docker volumes also, or Docker containers. Sharing file between containers in the pod is difficult. Right. By using Kubernetes volumes, we can achieve both the things, right. So how it is done? We'll check it. So can you see, as I explained, it is, or why do we need it? For data persistency, right. So whenever the container dies or the pod dies, volume preserves this data across format, and it supports, pods share the data using volumes. Alright people, so now let's get into practical of this one and let's check how it works for us. But before this, alright people, let's try to understand about PV and PVC. What do you mean by these two things? Right, with a particular analogy, right. PV stands for persistent volume and PVC stands for persistent volume claim. So how this works, let's try to understand here. So imagine there is a bank which is offering, or they have a locker service. They have what? Our locker service. Different lockers they already built and they kept there. Now, customer will visit this bank. Can I say customer will have his own requirement? Let's say for example, he is looking for a particular locker which has 4x4 size or some of his requirements, and bank has created lockers with the different requirements, like one locker can be 4x4 size, one locker can be 2x2 size, right. So multiple other options. This user, what he does is, he will visit the bank, he'll go around looking for all the available, storages. From that, he will pick a one particular storage which suits his requirement. Now, in this case, the storages which has already been created by bank, you can consider this as PV, persistent volume, right. Banks have already created persistent volume and it will be retained as it is, and he is something called as PVC, persistent volume claim. They have already created this option. If the user's requirements matches with the available storage, then automatically that will be called as a match, and he will claim that particular thing, and there will be something called as binding, PV and PVC binding. This is a perfect analogy of persistent volume and persistent volume claim options. Right. Let's go back and let's check it how it goes for us. Right. Now what you do is, once you're done with these things, let's move ahead and let's check practically how can I implement these two particular options. Right. And there is one more option called as PV and PVC binding, like I mentioned. Right. Let's try to understand this persistent volume and persistent volume claim, how this binding happens properly. Right. But before this, we need to understand something called as access mode. Something called as access mode. How this access mode works and what is the exact requirement. Right. Let's move into that particular thing. Alright people, as you can see here, the main access modes are read write ones. Right. People, just imagine there is a node, minikube node, right, where if a volume is created in this node, of course, when volume is created in this node, right, he says only this node has access to this one, correct? Can you see? Read write once. Only this node has access to write on this particular volume, but multiple pods in the nodes can access this volume. That is, multiple pods, if they have, they can access this particular volume. Got it? That is what read write once. Now, the second option here is read only many. Right. In this case, there might be a volume and multiple nodes, like 1, 2, multiple nodes, as well as multiple pods can read as well as write once onto this particular volume. Right. Multiple nodes and multiple pods can do what? Read write into this particular volume. Then we have read write many, correct, where what happens is, if there is a volume, right, so in this case, multiple nodes as well as multiple pods can write onto this volume simultaneously. Right. We can have multiple nodes, right, they can read write, or many pods or many volumes can read write onto this volume. Right. That is what it says, read write many option. Alright people, the last one what we can say is read write once pod. Right, and it has been introduced from version 1.29, as we can say here, and this can be mounted as read write by a single pod. Right, only one pod can have access to read write kind of stuff. Can you see? Ensures only one pod can access this volume in a read write mode point. Correct. Alright people, so this is about the access modes. Now let's try to understand, once we have access modes, how this thing works. Just imagine there are multiple PVs created. PV. Multiple PVs has been created, that is your persistent volumes has been created. Right. It can be 2 GB, it can be 10 GB, it can be 15 GB, right? When you try to claim it by using PVC, it makes sure that it matches certain criteria. For example, your PV claim is 3 gigabytes. Your PV claim is 3 gigabytes. What it does is, obviously this thing is excluded from the race. So he will try to access this particular pod, PV. The 2 depends on, for example, if you see this option here, what is this? Read write once. Just imagine he has read write once and he says read write many. Read write many, right? So PVC, when it tries to bound, after looking into the storage size, he looks into RWO. This is his requirement, right? So what it does is, this volume claim will try to bound with this thing. Reason for that is, your read write once is matching, as well as 3 GB claim is also matching. And of course, so once this thing has been bound to this string, almost 7 GB of storage will be wasted, right? Only once you can have this claim and it will be in a binding options. All right. So with this, let's move on to our practical sessions. Let's try to create first one particular PVC. We'll try to create PVC, then we'll try to mount this onto one particular pod and let's check how it goes. All right, people, as you can see here, I'm trying to create a persistent volume, right? By name PV and storage capacity, I'm just considering as 10 gigs. And what is the access mode? Read write once, right? So there is one more thing here, that is persistent volume reclaim policy. See, you can set this to delete also, means if you don't want to retain once the pod is deleted, automatically even the volume will also be deleted. Even we have that facility, but there is a reason why we are going with persistent volume. It is better to retain this one. Of course, that is what we are doing now. And it will be mounted on the host path of, on my local system, MNT data. It will create on my local system MNT data path where this persistent volume will be retained, right? Let me go and let me create this PV right now. Can you see? A PV has been created. You can check this whether it is created or not by using the command PV. Can you see? My PV has been created, but then I'm 10 GB. It has read write once. Reclaim policy is retained. What is the status? Available. Claim has not yet been done. Reason for that is I have not created yet PVC. Right. So let me go back, let me create a PVC, then we'll check how the status will look right now. Right. Let me apply this one. F1F. Can you see? A claim also has been created. Let's check with this one. kubectl get PVC. Can you see? My claim status is bound already, right? And PV is my PV. It has bound with my PV. Capacity is 10 GB, right? So my PV or PV capacity was 10 GB. That's what it's saying. It has bound. If I change this one, instead of read write access, if I use something else, then the bind will not happen, right? Let me go and let me claim or let me check kubectl get PV. Let's check what output he says there. Can you see? Status is what? It is currently bound and it has been claimed by which person? Default my claim. Got my point, people? How it works for us? So that is how you create a PV and you create a PVC and you bind this both the options. But that's not it. Let's go and create a deployment and let's try to use this volume inside that particular option. Let's check how it goes. Right, let me show you this one. Can you see? Everything is perfect. The only thing is, the only changes, not changes, the things, how the things will change here. That is a persistent volume claim. What is the name of the claim? My claim, right? And that claim name is /MNT/data. Right. That is what we have saved there. That will be bound with your pods, your pod or your containers, this particular path. I mean, whatever the data you have here, you can access from the host machine's MNT data, right? Let me execute this one. Let's check how it goes for us. Is there any issues? Fine, let's check, Yep. Yes. It has been created directly by us. Got it, people? So that is how we create the volumes and we make sure that volumes are utilized inside your deployment. But see, as of now, there is nothing inside here, but you can enter the pod, you can do kubectl, exe, it, and you can create any sort of data there, and the data will be reflected back and forth. All right. With this, I'm going to just close this volumes concept. Thank you very much, people. We'll meet in the next video. If this session has helped you learn about Kubernetes, do hit like, share, and subscribe button for Star Ajay. I will meet you in the next video. Till then, keep learning.